Good evening, everyone. John and I starting OPIS1 today, and we had last week orientation about the various informal tools that we have on this program for the learning. All of them is developed by UNC in Chapel Hill under the uh, program that they developed since early 2000. We're gonna go over the basics of this remote telescope access and also basics of the astronomy in the sessions. We expected that we have a 2 week because this is lab one and we have lab 9 lab. Lab one to lab four we consider as a Opus 1, Lab 5 and 6, Opus 2 after completion of the 4 labs, and Opus 7 to 9, that is radio astronomy and the entire universe. It's gonna be on the Tuesdays. We developed those for you. But regardless, this lab one is essential for all the offices. Therefore, main, and it's gonna take more time, but you will learn very good tools on this lab, and it's gonna be beneficial for future astronomy course hobby or kind of work you're gonna have in your life, and also it's gonna be very helpful on the astrophotography. This course is not mainly astrophotography, but the things that you learn, it's gonna be very uh, precise and good to learn astrophotography as well. Okay, before going forward, John, you wanna say something before I start of the showing the steps?
Yeah, definitely. So a priority immediately is to try to get the Skynet working for you, get yourself logged in and learn the basics. And the next couple of weeks, that's what we'll try to make sure everybody gets to that point where feel very comfortable using it. And on the website and the assignments, it tells you how to have the settings. And so that's something we'll try to keep bookmarked. And I'll try to drop in a link where I have Google Drive we can all kind of share. And as we're going through this, what I always try to say is we're learning together. So Abbas and I have been through this a few times, a few. One was very quick, so I'm not sure it's a few, but we're becoming familiar with this also. And as you learn little tricks, you find some shortcuts of things that you want to share with the group. Feel free to do that. But we're going to be learning about robotic telescopes today and how you access those and turn these on and the settings that makes everything work. So it's a very important day and hope you have a lot of fun working through this. And thanks. I'm glad everybody's here.
Thank you, John. Any question before I start from anyone for the overall class and other material you may have in your mind? Hearing none, let me share the um, material quickly.
As you're setting up, I have a couple of things, my last notes I had. I usually say this too. You won't use very many credits doing what we're doing, but one thing we'll mention that about being kind of careful with watching the amount that you use. I haven't had anybody run out, which isn't going to happen. But we get there, we'll talk more about that as we get into that point.
Hopefully you see the screen that I'm sharing. This is a web assign when you log in on the uh, access by the access key, class key that you provided. You're gonna see the inside this class is called Astro 100L. Astro 100 is basics of the astronomy learning that is developed, and the Signet and WebAssign is a third-party agency that provide this classes and assignment and grading and things like that for various online courses. But this one is not like regular credit or online courses, although you're going to get the certificate after completion of this course, but it's not like a passing or failing. You have to take it in more because this is kind of help to learn material out of the regular credit and school for you, and it's gonna be beneficial, hopefully, for entire your life. And here, as you see it for each lab, uh, tell me when I sharing and describing, if you don't see it, let me know because sometimes I cannot see it from your side that you can see it the page or no. Uh, lab one and the lab one that we're gonna start today. You see several icon on the front that you can click. This is view. You can view it inside what is inside the lab. The reason they call it lab because this is a laboratory. It's not like a lecture course. The things that you can go and learn, and also we're gonna provide some tips on many of them that we learn, and probably you may find yourself some tips, then you teach everybody else as well. It is not like a one-directional teaching or learning procedure. And as John mentioned, view is just providing the view of the material inside the lab. And the lab is, I call it, hands-on activity, and like the one that you're doing on the lab, either by your telescope or remote telescopes or your experimental way. And here the schedule and the kind of things that you see it here, although you say this date, I gonna change it those later on. But this one, assuming that you're gonna be available for you from now to sometime end of the December, and hopefully by early January, if we can extend it. Therefore, you may have more than 3 months opportunity to do that, but don't wait for the last minute. Just start as soon as you can on this material. And also same thing for other courses. We're gonna try to make sure that all of them is become all the courses gonna be active for that period, but you're gonna pay only for one of them. You don't need it to pay for all of them. And I specified one on the email that you're gonna register to that. Make sure that you have enough material on this course, and after 2 weeks of the when after the YOLO login, normally automatically after 2 weeks, free trial is gonna disappear, and you need to pay it $65 to access to that one. This is only access the features that administrators on Signet Vivasan created for this class. Okay, we go to the first view lab one in here. As you see it, you will see it inside. You can go with your WebAssign as well to see the material accompanied with the material we just providing here. You see it on this section, Introduction to Skynet. Skynet is the facility that is provided. I will show it to you here as Skynet is the one that is for the observation, taking the remote pictures you're going to use. But we're going to have some introduction section, instruction, background, and procedure 1 and 2. Probably we're going to reach end of the procedure on the week 1 today, and we're going to go later on. Several important items that is needed to be noted. Here is identified by the bold. You needed to read those and make sure that follow on the remaining part of the lab 1, 2, 3 to 9. Uh, it means we have some object we identify. This is very important. Some object we needed to identify. You can take a picture and observe and take a measurement, but it doesn't mean that you can take all of them. Not all of them might be observable. For example, sometimes one of the object, either planets or galaxy, is behind the sun, and therefore you cannot take a picture of that, or very close to the sun or moon. Therefore, sometimes we will go through during the session how you can identify those also with different tools, but it doesn't mean that whatever we have on the this OPIS 1, 2, 3, you're gonna observe all of them and you have to submit all of them. No, you cannot do that. That's because of the evolving and dynamic future of the star and galaxies and other objects on the sky. Therefore, as much as you can able to observe them, either you probably you can observe in few days or few weeks. But if you wait for the November, it may not be observable. Therefore, you have to make a management to make sure that observe the tool's object as needed as soon as possible before it gets close to the sun or become on the daytime that you cannot observe it and take a picture. Therefore, this is kind of we're gonna provide a guide for you how to do that, and that's gonna be a very good tool for you. And the other thing is that important here, you for the submittal, we're gonna see the submittal down the line that we're gonna see how you're gonna submit your pictures and your measurements to the lab, different labs. And there is no limited number for the submission. You can submit 100 times, or I will say 200 or 300 times. There is no limitation. But the last one that you submitted, it's gonna be accounted for your grading. Grading means that how much you capture the fact that is important to the observational astronomy. Therefore, as much as there is no limitation, it means that if you submit one time and you notice something is wrong, you want to make it better, you can come back and submit again. It doesn't mean that you submitted one time wrong, it's going to account it as a wrong item or information for you. Therefore, it's going to consider the last one. Next item is important. WebAssign do not confirm your submission. When you submit, it doesn't say you submitted one time, two times, or you did it or no. The best way that you do it is that you keep a logbook for yourself and mark out whatever submission you did it, and make sure that you have good enough kind of control on the submission of the assignment and the task that you needed to do. The next item is that all calculated values has to be three significant digits. This is very important, unless on the specific assignment they say differently. For example, if you have we normally use on this here because the numbers are very low or very high, might be we needed to use scientific notation. Scientific notation is a decimal number here with the letter E. It means exponential. It means the 10 power. Instead of the writing right is 10 power 3, we're writing E power minus 3. Instead of the 10 power minus 3, we just wrote this way. And therefore, this is a scientific rotation that we needed to consider. And if we consider uh, significant digit here, how much significant digit you're going to have here. Then you have to consider always three significant digit unless you identify accordingly. We're going to go on the next item as an example to see how it's going to be united. And also, another important fact is that normally on the physics or other chemistry or other science subject, one of the key items that you have to provide is unit. If you don't have a unit, it means that the number itself doesn't say anything. If it is meter or kilometer, mile, or different units is very important on all the physical parameters and numerical calculations. But here on the lab that we have on OPIS, you don't need it to provide units. Units already given over there. And therefore, you don't have to worry about the units as long as you provide the significant digits and scientific notation properly. And another thing that is important, do not use specific characters when naming the object. We're going to go over here when you have to name, for example, if you're taking the uh, for example, a picture of the Jupiter. You can call it Jupiter, your initial and the date, something like that. But you cannot name it as a kind of a special character like a dollar sign or semicolon or others. Therefore, WebAssign do not accept those as a kind of legitimate uh, specific characters within the name of the items. We're going to go an example. We're going to repeat this one again. Any question on this main basics of the information on the OPIS? Hearing none, we go to the next item. Is the lab one, the main goal that we have is this four item. We observe the astronomical object with the University of the North Carolina Prompt Telescope. We're gonna see which telescopes are there. They are located in Chile, Australia, and Canada. And also, there is many other telescopes available that is connected to the UNC Skynet Robotic Telescope Network that is not belong to the UNC North Carolina and Chapel Hill. That we can use those. We're gonna see each one of them separately. And we can adjust the brightness and contrast level of the astronomical images to better view them. We're going to look through an example of those and also measure angular size of the images on the picture. And those are very key items on the astronomical observation. And also the next item is that identify objects in your image that are moving through the part of the sky. And this is the one of the key items that we have to identify what objects are the planet and what objects are the stars not moving on the sky. The only equipment you needed, a computer with internet connection. That's the only tool that you needed to have. And the next item here, we're going to go background information about the prompt telescopes. This is a view of the uh, dark sky in the Andes on the Chile, on the Cerro Tololo, and the mountain is about 8,000 feet above the sea level. And this one, as you see it, the Milky Way is very uh, clearly you can see by your eyes, and you can see many star over there. You cannot identify the constellation. And that's one of the amazing places. It's dry and high elevation. And there is many, almost more than 50, 60 telescopes are there. And not all of them belongs to the UNC Chapel Hill, but a few of them. The others belong to the other universities, other scientific organization across the globe. Some of them belong to the Europe, some of them on different university of the United States or Canada, and some of them belong to the Jap, uh, Japanese space station, and many other organizations. This is another prompt telescope in Australia. You see it. This telescopes, as you see it, is located and converted in this location, this picture. And those are the uh, controlled by the domes. When it is you assign it the telescope to take a picture, if the weather is good, it open up and take a picture for you and make a assignment. If the location is cloudy, the dome is not going to open. Therefore, you don't have to worry about the when is this weather is good or no. Because of that, it may take many days or many weeks to take a picture because of the weather or location of the object on the sky that we're gonna go over. And all of them has a dome, either the one that is on Chile is showing and also the one on Australia. And this is we're gonna go over many of them during the course as we go further. One of the key item that is this is very important from my point of view, from historical point of view, why this idea comes to the Dr. Dan Reinhardt and the group to develop this kind of um, learning tool that is almost more than 25 years, more than many thousand people get trained free of the charge of the tuition for this astronomy and access to the universe. And this is actually at the many years ago, early about 25 years ago, there was trying to observe some specific object in universe. They call it GRB or gamma ray burst. That is one of the very iconic and uh, kind of very exotic um, objects in the sky far away from us that cause due to the death cries of the massive stars. When a massive star dies or destroyed, that GRB created. And this is kind of artistic conception drawing. It's not a picture. And it shows that GRB biggest bangs since the Big Bang happened, and they are very close to that and very luminous, close to the Big Bang area and far distance. And they are so luminous that they can be observed by a small telescope like the one that you see it on the Cerro that you highlighted on here. You can observe it with this small telescopes as well. And then they took opportunity to take the pictures from these small telescopes. And based on their calculation in 2005, almost 20 years ago, one of his undergraduate, Joshua Hersley, and Dr. Reinhardt, is get the prompt telescopes to discover the most distant explosion in the universe. It was about 12.9 billion light years away. And since the universe is about 13.8 billion years away, it comes to their mind that they observed the star observed they died. This observation happened only when the universe was 6% of its current age, and this is over 8 billion years before Earth even formed. And this is kind of mind-boggling and also very good things that when not observing, for example, this may take a few days or it's not 24/7, but it takes a small amount of the time for all the telescope that is available for UNC Chapel Hill. And then it comes to mind that when not observing GRBs, over 90% of the time, prompt is used by other researchers across the state, country, and world by students of all ages, graduate, elementary, and the public. And this is the way that they created. If they didn't do that, that kind of 90% gonna be wasted and not gonna be available for the people to observe it because these facilities are there and if we're going to focus on only one research not going to be sufficient enough and that idea it's promote astronomy and observation and research more on the globe and also more on the public. That's the main idea that Dan created this Skynet system by you see his picture here beside one of the prompt telescopes on a scale. As you see it, it's taller than the professor as well. And it is important to locate that the most important part of the telescope is the mount. As the mount is the devices. You see this is telescope, and this is a mount that is sitting and rotating around it. Why it is important mount? Because mount needs to able to point and track the motion. Sky is moving, the telescope and itself has to move uh, and cannot be become offset. Otherwise, the picture is going to be blurry. You're going to see later on. Therefore, prompt telescopes took different, most telescopes that are open instead of the using those. And this is features that each telescope you see it. The light, if we take one of the light, one of the point light comes from the object, far away object comes here, and it's gonna reflect on the primary mirror, gonna go to the secondary mirror, again reflected to the center, and it comes to the filter here we're gonna see the filter, and then it goes to the camera at the back and take a digital image. And this is a mount that is make it. This is the heart of the this device. If the mount doesn't work, and this is a technology that in the last 30 or 40 years become more uh, attractive and more useful. Otherwise, the other we cannot observe and take a picture for the faint objects. This is one of the key filters that we have on using on the These telescopes, not all of the telescope have the same filters, but some of them may have, some of them may not have. We're gonna see it. Filter wheel helps that when they take a picture with different filters. There's red, green, blue, and also the others are for the for the light pollution, and also ultraviolet as well exists. This is a very good example to show that basics of the astronomy and also astrophysics, the pictures that we have. When you're taking for example, this um, bird that you see it on this picture as a parrot, then when taking by the filter of the red, it looks like this. And when you're taking by the filter of green, it's gonna be like this. But when you're taking but blue, it's gonna be black and white. It's seeing like that. It doesn't mean that this is a black and white, but the picture that is taking, they have enough information on it that we can convert it to the red, green, and blue on the post-processing or other tools that we're gonna have. And when we combine it together, we're gonna get the real picture that we see it with our eyes. And therefore, this is one of the key features how we can distinguish the objects on the sky by the this uh, this combination of the filters and colors. Okay, next we're gonna go to the Skynet to learn. I step by here if anybody has a question.
And I'll go ahead and post the link for Skynet, and we'll see if everybody can get in and get logged in okay with that. And we'll take a little tour of how that works then.
Anybody has a question so far the material we mentioned?
Is everybody
No?
able to log into Skynet? You good on that? Okay.
And also
Everybody's
we
having trouble,
needed
let's
we
see.
need yeah, we needed to have both a WebAssign login, you get to use to it, and also Skynet. Therefore, we able to go pass through the other parts as well. Let me go over the Skynet. Uh, I will see you here. Let me log out myself. This is the first time that you come here. You see it, this picture here. We have several tabs: Home, My Observatory, Sky Live, Skynet Live, and this telescope site and help. Here, the home, the main things that we're gonna work on here, My Observation, and you go when you go observation, you put your login name and login and enter the main session. But before we go with that, we look through here to see what we see it. Here, you can log in here as well. You want to go or you go here, my observatory login. Either way, you can do that. As you see it here, we have 13 telescope right now is online. That's always is changing during the time. When login, you will see different numbers every time. And here, as you see it by now, we have 21 million images taken by this Skynet. And that is amazing that how this during the many years it has evolved. And the telescope efficiency also changes. For example, sometimes, for example, based on the technology and information that they have. We're going to look through it how we can benefit on that. But each of them has different efficiency on taking the picture because of the tools that is incorporated. And here there is a very small items that is available here that is not belong to us, but for other features of the this Skynet uh, kind of tools. Next one is Skynet Live. When you click here, you can see it which telescopes are active and which one is not. For example, this telescope, it says whether it's bad or camera error we have. When camera error we have, it takes time to make a correction. And also here is idle. It means this is free that you can take a picture. Green bank is a radio also observation. And here as another one is bad. This is the good, but the weather is good, but the camera is bad. And here is the dome. It says dome is closed. The dome is closed, and the radio astronomy there is no dome. you see NA here. And here, you see here, one of the telescopes is weather is good, is idle, and the dome is open, and nobody taking pictures, but probably waiting to take a picture, somebody. And here as well, you see many of the telescopes are in bad condition, the weather-wise, and the telescope are good and active, but they cannot make a picture because the weather is bad. And right now, you see, this always is changing as you go minute by minute. Next one is the telescope site. You can go here, telescope site, look through it. This is American Public University Observatory, and it gives you some information about the location and what the elevation is located, and you can take a location weather condition in here and some other features. Or for example, we go Cerro Tolula in Chile, and you see on the Cerro Tolula we have four telescopes, and this is a live view of the picture, although it's closed, it's black. You cannot see anything. And similar thing to the other ones. This is one of them is Moorhead Observatory on the Chapel Hill, and this is the information about the elevation, and all other data is available here. Okay, then we go for our main purpose. You go to the main observatory, log in. When you log in, you don't see anything here. You see something here, optical observation, because I take some pictures before. You see something here, but when you log in first, is everything is here empty. You don't see anything here. You don't worry about that. They're gonna be filled out those eventually. And the things that you have to make attention here, this key toolbars on here. As you see it, observation list. This is the title. The first choice is add a new observation. Second is campaign list and new campaign. We don't need to use this too because this is for a specific group activity with many scientists or students together. And we normally use this one, add a new observation, and the last one, open afterglow. That we're going to go later on open afterglow is that. But the first thing you have to do, add new observation. And you see another options here. We're going to look through it later on this activity. Before going to the observation, I want to say something here. In the group that we have it, I see we assign it 1800 credit for you to take a picture, but I don't see it. Some of them you already registered, your name is here, and I see your name is available, but many of you may not have I see this designation. It is kind of username that assign it automatically when you register for the class. You may need it to go and assign proper login name for yourself. The reason is that when your or what you call it, the image is going to happen, it's going to designate it by this username. And if it is not very easy to remember, it is going to be very difficult to find it on the archive of the uh, Skynet images. Therefore, I recommend that you always assign a proper username that is easy for you to remember, and keep in contact and have them ready for your activities. Okay. Then we go to the first step, add new observation. Okay, when we're gonna add the new observation here, we're gonna learn a few tools on here that help us to see how it looks like. Here, the target finding interface. Here is the target finding sky viewer. This is a graphical display that shows the sky above our head. This line that you see it is a kind of one line. As you see it here, you can identify various things here as needed. For example, normally we're gonna see uh, different things here. We're gonna learn how we're gonna look through it. But basically, in here, most of the objects are observable. If you wanna see, you don't wanna see a star, you don't wanna messier objects, and you don't wanna see sky brightness, you can make it away. But if you want to see only solar system, how many of the solar system you can see it? Jupiter is here, Uranus here, Neptune and Saturn is here. But the thing is that if we identify those uh, among the stars, it's gonna be, and also other object, it's gonna be very. If you identify all of them, sometimes it's very difficult to identify. It's better to identify what object you want to see. Therefore, it gets your chances better than usual to find the object on the sky. Then, right now, probably the time that you see it here is based on the uh, observatory that different observatory point of view. It's because each of them is located on different location. You can identify because we are close to the Moorhead. You can identify Moorhead as a kind of sky that is closer to us to observation. And if you change it the hours and days, you see this sky and object gonna move, and it shows that how it looks like. Right now, you see the sun. When you see the sun, therefore, shows the daytime. And as the time that goes past here, then you can see it after sun is disappear, you can see the other object. Mars is here, Moon is here, Pluto is here, Neptune and Saturn here. Probably it shows that Mars is closer to the sunset on the west. Moon is after that, then Pluto and Neptune and Saturn. And then when you go further to the morning, you see the Uranus and you see the Jupiter and the Venus and then Sun. Therefore, this is the sunset, sunrise, and then we repeat this cycle again. This is the sunset. Okay, this is kind of global view how to find the object here, but you don't need it to worry about that because this is kind of graphical representation. And for example, I will assume I make it very kind of randomly located somewhere. You can identify here uh, different uh, time of the year to see the sky. For example, sunset. Based on the sunset you're gonna observe, or based on the sunrise, or based on the midnight or noon. But this is not important for us. This is kind of information for you. The important things is that after you come here and uh, you wanna do observation, say I wanna observe the Jupiter. I put Jupiter name here and search, and then he highlight the Jupiter for you with this icon. You see this a circle with a plus sign on the middle. Therefore, this is shows where is the Jupiter located. And then we have we have some information here that is important. This is the one information that we mentioned here in the class that we said make sure that you have when you assign the name, you don't have to use the special characters. Only you use the names that is relevant for you. For example, I put Jupiter, my initial, and right now is September 25, 2025, something like that. Or whatever, it's not mandatory to choose this format, but whatever easier for you, because you're gonna have many others observations. If it is designated for you than the others and specify object, it's easier to find the material on the images. Next one is the right ascension. This is a coordinate that we're going to learn, a coordinate of this object on the sky. We go, the other object, these are automatically calculated by the Skynet. You don't have to worry about that. And the other thing is important here is that two things is important. Minimum target elevation. This minimum target elevation, it means that if the object, either Jupiter or any other thing that we choose, if it is about 30° above the horizon, it takes the picture. This is a limitation. It means that if the object is 29 or 26 or 10, it doesn't take picture. Why? Because it is close to the horizon. And what's the problem on the this when it is gets closer to the horizon? Any idea? When the object is very close to the horizon, why is not better to take a picture?
Things can get in the way of like the telescope, like the light going into the telescope, like buildings and stuff, or like trees.
Yeah, several reasons. It will become very close to the sun, and normally when it is no, no, when it is dependent on the location of the star. If it is, for example, 35 degree away from the sun, and the sun is on the horizon. Therefore, it's going to be very illuminated over there. But the main reason is the atmosphere, because when you go to you can see the atmosphere here. When you go on this direction, you have thicker layer of the atmosphere between you and the object. Therefore, the uh, the picture might be blurry, might be not very good, but the best way that to observe the any object is right on your top of your head. We call it zenith. That's the best place. But we cannot wait for all the object come to the zenith to take a picture. We put some limitation. We say we don't consider taking picture about 30 degree about the horizon, and then based on that we kind of go over determination of the or observation on the sky. Any question?
And as we do this, what you'll learn is, the higher is the better, but sometimes you won't be able to do it. So, like Venus is something that's really close to the sun right now, and it'll never go very far from it. And if you wait for it to be 30 degrees away from the sun, it's never going to happen. And so we realize that we have to wait till the sun sets. And so that number might go down from 30 maybe to 20 because that's how close you have to come to get an image of it to have any chance. So these are great numbers to start off with, and the guide here, which we have, kind of is our starting point. And we'll do things later on, like if you want a really clear image of something and you know it's high in the sky, you might tell the robot wait to take it. Other times, if you're desperate to get the shot, we'll let some of these numbers crawl down kind of low because we can't shoot right next to the sun and we can't go through all the atmosphere at the edge. But it is about trying to get the shot sometime that we want to get. We want to capture that image too.
Thank you, John. Any question? Okay, we go back here. Therefore, here normally we specify 30, but sometimes we can go down to the 15 degree as well. Therefore, in some occasions we may able between 15. Uh, we recommend that we don't go below that 15, but this is not a Bible or it's not a kind of deterministic. You can go sometime 10 and try to see how the object gonna be work. But based on the professional astronomers' recommendation, is almost minimum is 15. The best is 30 that you use. You can range this target elevation as needed between 15 and 30. And why it is that based on the actual practical experience that astronomer had during the observation. The last item that is gonna important here to consider and also is important to maximum sun elevation minus 12. It means that sun has to be below the horizon about 12 degree. And that's the reason also to avoid the kind of luminosity of the sun, prevent faint objects or other objects on the sky. The other important item is that the minimum moon separation. Also, we're gonna a minimum target elevation about the atmosphere, and this one related to the sun, and also this one if it is object is very close to the moon, because moon is very bright, we may not able to have a good picture of the object. That's another reason that we provided 30 separation. Normally is better, but you can change it this one as needed to 20, but your picture may not be good enough. But the best option is that 30, 30, both of them, target elevation above the horizon and also 30 for the moon.
Yeah, this is
These,
one time that map up ahead above is really handy because you can show you where the moon is located next to something you're trying to look at. And so most times I don't worry about that because I've already looked to see if the moon's on the other side of the Earth compared to the planet I'm looking for. So I know it's not going to get in the way. It's just if we're taking observations and you notice that the moon is right next to your planet, the robot probably won't take picture for a few days until the moon passes its location and it can take an image. The moon's basically going to move about an hour, one of those lines across every day. So it slowly crawls 27, increments around. So that's one thing you always be aware of. Always look at the globe when I'm doing things to see where the moon's at, and hopefully it's far away from everything I want to do.
Very good. Thank you, John. And also remember that this tool is only this is a guiding the remote telescope that taking picture for us. Therefore, based on this guide that we're providing, you don't have to worry that when it is ready to take a picture or no, the telescope gonna computer system of the telescope gonna measure and take a picture based on your recommended value that you provided here. These items, other items are not important for us right now. Advanced setting, we may go in future as needed, but just ignore those. And this another important item is here. This is kind of target visibility over 24 hours when sun is below 18 degrees. Therefore, this shows that Jupiter that I'm going to take a picture observable on only one, two, three, four telescopes. Therefore, this telescope and each of them identified by the different color, by this telescope and this telescope may not be observable. Let me change this one, for example, instead of the 30. As you see at 30 here, this is 30. This is line. This is line of the horizon. You see it on the graph. Then if we change it this one to 10, you see what's going to happen. This graph automatically, this gray line, drop it to the 10. Therefore, you can able to observe with many more telescopes as well. But the problem is that on 10 degree is going to be not very good picture. Therefore, we keep it 30 and see which telescope we're going to see it. This is the first step for the observation. There, you identify what you're going to do based on the object that you want to say, enter it here, search. Then the search, name it, make sure to name it properly, identify the minimum target elevation or minimum moon separation. If you do it one time, next time when you're going to observe other object, for example, next day or next hour or next few minutes, you want to observe Venus or Pluto or other object. When you come here, whatever you save it here, it's going to be stay there. Therefore, you don't need it to change. Only thing that's going to change this observation name, coordinate, location of the object on the sky that automatically calculated by the system. As you see it here, there is an important item. This is the steps that we needed to take a picture. First, we identify the target. Here, we identify the target is Jupiter. Then we're going to identify the filters. Then we're going to identify the telescopes. Then identify the exposures. Then at the end, before submittal, we identify the review. For the filter and the telescopes and the exposures, we have some handy guys on the lab one. If you go to the web assign, after you go to the different areas that here that we're going to go over later on. For example, if you want to observe the planets, here observe a planet, there is a table here. This is an initial guide for you provided by the professional astronomers and Skynet expert on that. For example, if you want to take a Venus, you're going to use the filter U and you're going to have a exposure duration 0.03. For example, Jupiter, you're going to use the U and we're going to see what's the U in few minutes. And then exposure duration is 0.5. When you're going to observe the Neptune, you're going to use the filter B and you're going to see duration 3. One question, why the Venus and Mars 0.03 and very low number, but Neptune is 3 second observation exposure we needed. It means how much time that the shutter of the camera and the telescope gonna be open to make a good picture of the Neptune. Why it is longer on the Neptune compared to the Jupiter? 6 times longer. On the Jupiter, you take half a second. but on the Neptune, you need a 3 second. Why?
Because Neptune doesn't give off much light.
Exactly, because the Neptune is very faint. You cannot see it by your eyes, but we can see by our eyes Jupiter and very bright. The object that is bright, we needed less amount of the duration. The reason the exposure duration is that, for example, when we see it with our eyes, we just see it in glance of the second that we see the light of the object, and it's recorded on back of our brain and we just say it. But the camera is different. Camera, it takes photons of the light in the duration of the exposure. For example, in zero point 0.5 second, it collect enough photons from the Jupiter to show it on your on your picture. But for the Neptune, because it's faint and very not very bright, it needed to be stay looking through the Neptune and take a picture longer because to get more photons of the energy and the light to able to show it the Neptune on the image. Thank you. Therefore, we go back here in Skynet after we specify the target and see location, we just click it here, save, choose the filters. We go to the next target. You see here, this is we pass this one, we reach to the filters. In here, you have to find U because we know that in here, Jupiter, we have to take a filter of U. You don't need it to memorize this. You can copy and paste on the Excel file. And I have a copy that I can share it with you as well. You can have it handy for other tasks or also for astrophotography that's going to be helpful to see what is done. Here we have different filter system that use it for different purposes. And you that you see it is Johnson and Cousin. And why they call it Johnson Cousin? Because of the some naming that they have. These filters are based on the designation photometric system, UBV filter system that is established by Johnson and Morgan. And this main means measuring brightness of the color in astronomy. This is one of the main uh, filters that we're going to use on here. Therefore, we identify U. But here you see another filter, astrophotography, narrow band or Stromgen and special purpose. Neither of them, most of the item that we're gonna use the Johnson and
Cousins.
Cousins in here. Any question? Okay.
That's good.
Then after the U we specified, we save and continue. And here we just has to see which telescope can be seen. Here, unfortunately, we have only, let me see, we have more. Yeah, we have two telescope. We can have it observation. We can identify both of them or one of them as you need it. And it gives you some information to what's the diameter, field of view, and pixel size. We're going to go over later on this one. But we're going to see here after target filter, we go to telescope, save and continue. And then on here, we're going to provide exposure. Remember exposure that we have 0.5 second here. Then we come here. Always remember, this is one of the rule of thumb. When you identify exposure, always use the generic 16-inch back illuminated CCD. Why we using this? Because these tables that is provided is based on the calibration with this generic camera. Then we come here, we see the filter is U, number of the exposure 1. We're going to take one picture. And what's the duration? 0.5 second. Then after we done, we have two telescope and we just say add. Sorry, after we done, we don't need it to add. If we needed another picture, we can do it this one. But because we, for the first trial, always try to use one exposure, one picture, and the specific orientation, the duration is given here. And then you go, for example, credit that you have here, we use it 1800, save and continue. Here, as you see, target identify, filters identify, and telescopes, and exposure. And then at the last, you have to review it. Make sure review all of them. Observation name is given this one. Target object is Jupiter. And this is maximum sound elevation, target elevation, and the separation from moon, 30 degree. And then these are the all other items. We're gonna look through it here. Telescopes that is choosing this one. And as you see it here, identify the Skynet. And at the last minute, it shows you this is very important. Is 1800 credit, you're gonna get 1 credit out, and you're gonna remain 1799. And then the last one, you submit. After you make sure that everything is correct as needed, then you submit. When you submit, it's gonna show some pictures for you on the last minute. Then, therefore, this identify for you on the main target. If we go back to the main observatory here, this one, it's gonna show you on here. Right now, I have observation, for example, here, it taking some of them. You see the observation canceled because of the weather or technical difficulties. Some of them is taking, but the picture is blurry or not good, and some of them is very good. And when it is completed, it's gonna show you here, your picture is completed. One picture out of the one picture. Therefore, this is the main procedure that we have for taking the picture. Adding the picture, target, filters, telescopes, exposure, review. Any question on this 5 steps?
So when you select multiple telescopes for the observation,
Yeah.
which one will it use? Will it use like the first one in the list?
Right, the first one
No, that,
becomes available.
yeah,
So depending
first,
on weather and conditions and all that.
yeah, exactly. As the depended on the many conditions, dependent on the weather, dependent on the availability of the telescope, dependent on the if the functioning good the telescope or no, and identify all of them here. For example, I can identify all of them here, but you see only 2 of them is available because why? The others are not good condition or weather is bad. Therefore, it doesn't take this one. And then at the end, when we go to the review at the end, it gives you these two items observed. But between these two, which one is getting the first opportunity to take a picture, it's gonna take a picture. For example, if the Moorhead on the Chapel Hill gonna take a picture, then it's gonna release the other one. It doesn't mean that it's gonna take 2 picture from 2 telescope. It's gonna which one is available first based on the weather, mechanical, and also other circumstances available. It's gonna take a picture and provide it for you. For example, if I go my list here, I may identify many object here. If, for example, I will identify here 3 object, but is only taking with one of them. We'll see which one is taking. Is a prompt 5. It means that go back here. You see this one and this one and this one is candidate. But why it taking by this one? Because this one was the first available to take a picture. Then it released the others. Any
Yeah,
question?
if you've gone ahead and submitted that, which I did myself, and right now I have in my, it should come up as optical observations and your state will be active. And what's kind of cool about this is you'll see that change. I've been on sometimes and they'll see that they're actually taking it, then it becomes completed. But you can always come back anytime later. And for now, I would just focus on doing it. Just try to get an image to come in from what other telescope you can get. Down the road, you might be more selective with which ones you pick and a little more parameters. And that's what we learned. There's a nice, gentle learning curve to this to get the best images. Some would be more pixelated, some would be very sharp. But for now, just try to get one. So, was everybody able to go through the process? Or how many of you went ahead and you submitted something? Did everybody do that? Get a chance? Yeah. And did you get the state being active? Congratulations. All right. You're in the community. You've crossed the line now. No going back, guys. Guys, I'm sorry. We're there. So as
Thank
you go
you.
through this, you're into it.
Yeah, and also for the next week, I expecting you to try this kind of process 5 steps to able to see how many of them you can take it based on this table that is provided. That gonna be for the next week. Hopefully you're able to do it, but you may not able to have 6 pictures by the next week, but